Good evening, students. So let me continue up the MCQs of electromagnetic waves. So in the last class, we have completed around some 37 problems. Let me continue up with this. Epsilon naught and mu naught represents the permittivity and permeability of vacuum. Epsilon and mu represents the permittivity and permeability of the medium. Then how do you define the refractive index of the medium? You know that refractive index is defined as the ratio of speed of light in air or vacuum medium to the speed of light in the given medium. Speed of light in air medium to the speed of light in the vacuum medium is called as the refractive index. You know that speed of light in air medium is given by 1 divided by root epsilon naught into velocity in the given medium is 1 divided by root epsilon into mu. So n is equal to C value is 1 divided by root epsilon naught into mu naught divided by V is nothing but 1 divided by root epsilon into mu. This root of epsilon into mu, which is the denominator of a denominator, goes to numerator. So n is equal to root of epsilon into mu divided by epsilon naught into mu naught. So refractive index is defined as root of epsilon into mu divided by epsilon naught into mu naught. So option B is the right answer. Got it? Yeah. Look at the next problem. X-ray not used for the radar purpose because they are not reflected by the target. Actually, radar means it is a radio detection and ranging. Radio detection and ranging. Radio detection and ranging, where this radar is used to measure the long distances. Suppose if this is the material which is target, if I say this is the source, from the source I'm going to send the ray of light, and when it is incident on the target, it should get reflected back to the source. So by measuring the time taken traveled by this ray, you can measure this long distance d. So this is the phenomenon where the radar is going to use to detect the large distances. So mainly this radar is going to be used by the reflection phenomena. Whenever the radiation is incident on the target, it should get reflected back to the source. But X-ray is not going to be like that. X-ray will not get reflected by the target. X-ray will enter into inside the material where it undergoes the refraction. So the X-ray will not get reflected by the target. Since X-ray is not having the property of reflected by the target, it cannot be used for the radar purpose. Be careful. Now there are 3 types of radiation. One is alpha decay, beta decay, and gamma decay. They are carrying the same momentum. You know that momentum is nothing but mass into velocity. Which one is having the longest wavelength? Now, you know that the de Broglie wavelength for any particle is given by the formula lambda is equal to h divided by m into v, or lambda is equal to h divided by p. How the de Broglie wavelength and momentum are related? De Broglie wavelength lambda and momentum p are inversely proportional. But they are telling that all these rays, alpha, beta, and gamma, all these three rays are having the same momentum. They are having the same momentum. Then which one is having the longest wavelength? Since they have the same momentum, anyway, h is going to be a constant for all the particles. So if h and p are constant, lambda should be same for all the particles. Lambda must be same for all the particles. Therefore, for alpha, beta, gamma, they have the same wavelength. None of the options, all have the same wavelength. Why all the particles have the same wavelength? Because the momentums are same. The momentums are the same. If the earth did not have the atmosphere, what would be the surface temperature on that daytime? Definitely it should be higher, no? Why? If atmosphere is there, then the atmosphere will absorb the radiation. So partially when it absorbs the radiation receiving the earth will be less. So atmosphere is having the ability to absorb the radiation. Since the atmosphere has the ability to absorb the radiation, the temperature would get decreased. So if there is no atmosphere, then what is your conclusion? If no atmosphere is there, then the atmosphere will not absorb the radiation. If it is not absorbing the radiation means, if it is not absorbing the radiation means, the temperature would get higher, it would go high. So in the absence of atmosphere, the temperature would increase. So option A is the right answer. So which one is having the minimum wavelength? You know that the spectrum goes from radio waves to gamma rays. This is having higher wavelength. This is having lesser wavelength. So which one is having the minimum wavelength? Gamma radiation. Which is having minimum wavelength? Gamma rays. Which of the following shows the greenhouse effect? IR rays, infrared rays. Yeah. You know that charged particle with the charge Q enters a region of constant, uniform, and mutually orthogonal fields E and B. Orthogonal means perpendicular. Orthogonal means perpendicular. It is perpendicular to both E and B. This velocity V is perpendicular to both E and B. And it is going to come out without any change in the magnitude or the direction of V. Then it must be equal to what they are asking. Then what should be the value of E? Yeah. Let us take the options like this. E into B by B square, B into E by B square, E into B by E square, B into E by E square. Yeah. This can be analyzed like this. Now, the electric field is applied along the y-axis. And they are telling that the magnetic field is orthogonal to E. Let us say the magnetic field is acting along the z-axis. Electric field is acting along y-axis. How the charge is moving? Charge is moving with the velocity V perpendicular to both electric field and the magnetic field. So velocity of the charged particle is moving perpendicular to both electric field and magnetic field like this. Let us say the charged particle is Q. Now, this charged particle will experience the two forces. One force is due to electric field. The another force is due to magnetic field. Now, the force due to electric field is given by F equals to Q into E. Since it is acting along the y-axis, I am going to use J cap. Why J cap? Because that electric force is moving along the y-axis. So this is the force due to electric field. Now, this charge also will experience a force due to magnetic field, isn't it? What is the force due to magnetic field? It is Q into E vector crossed with B vector. You know that QEB, I is nothing but J, B is nothing but, instead of that you can take V cross B, Q into V cross B. V is acting along I and B is acting along K. So it should be I cross K. So Q, E, B. What is I cross K? Minus J cap. So you can notice electric force is acting along z-axis, that is Y. Magnetic force is acting along minus J. Minus J means opposite to y-axis. So this clearly tells force due to electric and the force due to magnetic are equal. Why this should be equal? Because they are telling that whenever the charged particle is coming, it is coming out without any change in magnitude and the direction. No change in the magnitude, no change in the direction. If there is no changes in the magnitude and the direction, what is the conclusion you can give? The two forces magnitude should be equal. The net force must be 0. the net force must be 0. In order to get the net force as 0, the magnitude of the electric force and the magnitude of the magnetic force must be equal. What is the magnitude of electric force? QE. What is the magnitude of the magnetic force? It is QVB. QVB. So Q and Q will get cancelled out. So E is equal to V, or you can say what is V? V is equal to E divided by B. So what is the velocity of the particle? It must be equal to the ratio of electric field to the magnetic field. So V must be equal to E by B. So what is the condition, students? If any charged particle is coming out from the electric field and the magnetic field without any changes in the magnitude and the direction. But the condition is the electric field and the magnetic field must perpendicular to each other. Then you can conclude velocity must be equal to E by B. Actually, this phenomenon, we call it as a velocity selector. What is this phenomenon called? It is called velocity selector. But option, they are not given in terms of E by B. You can multiply and divide by B. So E into B, that is E cross B divided by B squared. Multiply and divide by B. So E cross B divided by B squared, or you can say V is equal to E into B divided by B squared. So option A is the right option. Actually, the standard result is V is equal to E by B. But option is not given in that format. They have given in terms of B squared in the denominator. So instead of writing E by B, you can also write that as EB divided by B squared. So option A is going to be the right option. Got it? Yeah. Okay. Come to the next question. A perfectly reflecting mirror has an area 1 centimeter square. Light energy is allowed to fall for 1 hour. Time is given for 1 hour at the rate of 10 watt per centimeter square. Watt per centimeter square means intensity, right? Intensity is power by area. Now they are asking you to find the force that acts on the mirror. The force that acts on the mirror. Now, how to calculate the force? Now, intensity is nothing but watt per centimeter square. So it is something like an intensity is equal to power divided by area. Power divided by area. Then, can you calculate the power? It is intensity into area. What is intensity? 10 watt per centimeter square. Area is 1. So it is 10 watt. Power is 10 watt. But they're expecting you to find the force that is going to act on the mirror. How to calculate that force that is going to act on the mirror? Now, power is equal to force into velocity. So force is nothing but power divided by the velocity of that medium. Power is approximately, they have given us 10 watts. Now, speed of light, you can take it as 3 into 10 power 8. Since it is going to be the air medium, in air or vacuum, you can take 3 into 10 power 8. So it is 10 by 3. 10 by 3 is nothing but 3.3 into 10 power. When 10 power plus 8 comes to numerator, it becomes 10 power minus 8. So this is the force which is going to exert on the mirror. So if it is a perfectly reflecting mirror, if it is a perfectly reflecting mirror, whenever the radiation is incident on the mirror with a force F, since it is a 100% reflecting mirror, the ray should get reflect back with the same force. So the net force exerting from the mirror will be 2 times of 3.33, because 10 by 3 is 3.33 into 10 power minus 8. So the net force acting on that 2 into 3.33 will be 6.66 recurring into 10 power minus 8, which is approximately 6.7 into 10 power minus 8 Newton. So what is the force that is acting from the mirror? It is 6.7 into 10 power minus 8 Newton. 6.7 into 10 power minus 8 Newton. So that is option B. So only the thing you must know the definition, students, there. Intensity is nothing but power divided by area. Power is nothing but intensity into area. That is nothing but 10 watts. But you know that power is nothing but force into velocity. So force is equal to power divided by velocity. Power is 10. Velocity is 3 into 10 power 8. So 10 by 3 is 3.33. 3.33 into 10 power minus 8. Since mirror is having the ability to reflect, So it should go with the 2 times of the force acting on the mirror. One force when it is incidenting, the another force when it is coming out from the mirror, that is called the reflection one. So the net force is going to act will be the twice of that. So 2 times of that will be 6.666. That can be taken as 6.7 into 10 power minus 8 Newton. Yeah. Look at the next problem. An electromagnetic radiation has an energy of 13.2 kilo electron volt. Then the radiation belongs to the region of. Students, you know the energy is given by the formula E is equal to hc by lambda. Or the same formula can be used in shortcut, that is 13200 divided by lambda, where energy must be in electron volt. But lambda should be substituted in Armstrong. Now, what is energy they have given? 13.2 kilo. Kilo means 10 power 3. That is 13.2 kilo by lambda. Kilo will get cancelled out. Even 13.2 will also get cancelled out. Approximately lambda is going to be 1 angstrom. The wavelength range of 1 angstrom is for X-rays. You know that the wavelength range of the X-ray is approximately 1 angstrom. So the energy for 13.2 kilo electron volt. For energy of 13.2 kilo electron volt, the wavelength is about 1 angstrom. That is for X-ray. Now, out of this following electromagnetic radiation, which is having the shortest wavelength? You know that the shortest wavelength is for gamma ray. But in the option, they have not given the gamma rays. That means they are expecting which is the shortest wavelength among these 4. You know that radio waves, microwaves, infrared, visible, UV, X-ray, gamma ray. So this wavelength is more, this wavelength is less. So after gamma ray, for X-rays, after gamma ray, X-ray is the least wavelength. So out of the following electromagnetic radiation, which has the shortest wavelength? Which is having the shortest wavelength? The shortest wavelength is going to be for lambda, for X-rays. So option D is the correct answer. Okay. The fact of the radio signals reached the Earth from the outside the atmosphere was accidentally discovered by Jansky. It is discovered by Jansky. Now, in electromagnetic wave propagating along the x-axis. So the velocity is moving along the x-axis. Electric field maximum is given 30 volt per meter, which is nothing but E0. What is the maximum value of the magnetic field? Maximum value of the magnetic field is B naught, that is the question mark. So, speed of light c is given by the formula c is equal to E naught divided by B naught. So, c is equal to E naught divided by the B naught. From this, what is B naught? E naught divided by C. What is E naught? 30. C is nothing but 3 into 10 power 8. What is 30 by 3? 10. 10 into 10 power minus 8. This is 10 power 1. So it is nothing but 10 power minus 7. So what is the maximum value of the magnetic field? 10 power minus 7 Tesla. That is option A. You know that the ozone layer of the atmosphere lies in the stratosphere. Maxwell, in his the famous equation of electromagnetic, introduced the concept of what? Displacement current, no? Because you know that according to Ampere's circuital law, line integral of magnetic field over a closed surface is equal to mu naught times the total current enclosed by the loop. But this was failed by introducing the concept of the displacement current. According to Maxwell, the displacement current is the one that is going to constitute due to the time varying electric field. Due to the time varying electric field, Maxwell introduced the concept of the displacement current. What's the formula for the displacement current? Displacement current is given by the formula epsilon naught into d phi E by dt. Displacement current is nothing but epsilon naught into d phi E by dt. So this rate of change of flux is called an electric flux, E. So epsilon naught into E. Now in the next problem, they're asking you to find the concept of the electric field vector E, displacement vector D, and the polarization vector P for the dielectric placed in the electric field E is given by. So please remember, displacement vector D is given by the epsilon naught times the electric field plus the polarization vector P. Option C is the right answer. Please remember this concept. Displacement vector D and the polarization vector P for a dielectric placed in electric field E is given by D is equal to epsilon naught E plus the P. epsilon naught E plus P. Coming to the fifth thought, you know that electromagnetic waves is going to be deflected by which one? Electromagnetic waves can be deflected by electric field only, magnetic field only, both A and B, none of this. You know that electromagnetic waves is not at all going to deflect either towards the electric field or the magnetic field. You know that electric field is acting along the y-axis, the magnetic field is acting along the y-axis, the particle is moving along the x-axis with the velocity v. So the electric field and magnetic field are mutually perpendicular, but the particle is not moving either towards the y-axis or it is neither moving towards the z-axis, it is moving along the x-axis. So clearly this tells the electromagnetic wave is not either going to deflect towards the electric field or it is going to deflect by the magnetic field. It will neither deflect towards the electric field nor the magnetic field. So definitely you are going to be the option D, that is none of this. So electromagnetic waves can be deflected by none of this. It will neither deflect towards the electric field nor the magnetic field. Now, look at the next concept. Electromagnetic waves, this one, no? A charged particle is going to oscillate about its mean equilibrium position with the frequency 10 power 9 hertz. Then what is the frequency of the electromagnetic wave produced by the oscillator? It is 10 power 9 hertz only, because whenever the ray of light, the spectrum travels from one medium to another medium, frequency remains same. There will be no change in the frequency. So frequency remains same. So charged particle oscillates about its equilibrium position with a frequency of 10 power 9 hertz. That clearly tells the frequency of the electromagnetic waves is also 10 power 9 hertz. That is option C. So option C is the right answer. Why option C is the right answer? Because whenever the spectrum or electromagnetic radiation travels from one medium to another medium, there will be no change in the frequency. There will be changes only with respect to the velocity and the wavelength. There will be no change in the frequency. Please keep that in mind. And also remember, frequency is the characteristic of the electromagnetic wave. Velocity or wavelength is not the characteristics of the electromagnetic wave. Frequency is the characteristics of the electromagnetic wave. So whenever the electromagnetic wave is moving from one medium to another medium, there will be no changes in the frequency. So frequency of the electromagnetic wave will be 10 power 9 hertz. So that is option C. Coming to this. A plane electromagnetic wave is having intensity I, 10 watt per meter square. That strikes the small mirror of area 20 centimeters square, yet perpendicular to the approaching wave. The radiation force on the mirror is. Now, you know that the intensity is nothing but power divided by area. So this clearly tells the power is nothing but intensity into area. So power is equal to intensity is nothing but 10. Area is 20 centimeters square, that is 10 power minus 4. This is nothing but 200 into 10 power minus 4, or you can take 2 into 10 power minus 2 watt. So this is the power. So power is equal to force into velocity. So what is force? Power divided by velocity. What is power? 2 into 10 power minus 2 by, you know that the radiation is going to travel with the speed of light. So it is 3 into 10 power 8. Can you find what is F then? When 10 power 8 comes to numerator, it becomes 10 power minus 8. Already minus 2 is there in the numerator. So it becomes 10 power minus 10. So it is 2 by 3 now. What is 2 by 3? What is 2 by 3? 2 by 3 is nothing but 0.66 recurring. Since it is a reflecting mirror, the net force should be, you have to take 2 times now, as I said in one of the previous problem. Because the mirror is having some incident velocity and the emergent reflected velocity. So the net force will be 2 times of F. This is 2 into. F is nothing but 0.666 recurring into 10 power minus 10. This is nothing but 1.333 recurring into 10 power minus 10. So you can take option C as the right answer. Yeah. What is the order of the energy? X-rays, radio waves, microwaves. You know that radio waves, microwaves, infrared, visible, UV, X-ray, gamma rays. This is in the decreasing order of wavelength. This arrangement from radio waves to gamma rays is in the decreasing order of wavelength. As we move from radio waves to gamma waves, the wavelength will decrease. What is the formula for energy? Energy is nothing but hc divided by lambda. If the wavelength is decreasing, means the energy is going to increase. If wavelength is decreasing, energy is increasing. So, if lambda is decreasing, means the energy should increase. So, this is the increasing order of energy. When this is in the increasing order of the energy, first we have to arrange in the order like this. X-ray is there, X-ray, gamma is not there. So X-ray is having more energy. X-ray is having more energy. Radio and micro is having less, less than radio. So energy of micro, which is more than the energy of the radio waves. X-ray is having least wavelength. So energy must be maximum. And radio waves is having less wavelength, more wavelength. So less energy. So which one will be the right option? X-ray energy is more. They are telling X-ray of energy is less. This is not possible. This is also not possible because they are telling that energy of X-ray is less. So energy of microwave is more than X-ray? No, no. So options are wrong here. They have given. So X-ray is having more wavelength. X-ray is more than radio, but you can make it is less than micro. You can put that less than micro. So option C will be the right answer. Just you arrange the sequence from radio to gamma. So radio waves, microwaves, infrared, visible, UV, X-ray, gamma. From radio to gamma, wavelength decreases. You know the formula E is equal to hc by lambda. So E and lambda are inversely proportional. So less wavelength, more energy. So as we move from radio to gamma, energy must be more. So energy of gamma ray is more compared to radio. So I have arranged for X-ray, radio, and micro. So X-ray energy is more, radio waves energy is less. So you can make this condition. Or if you don't alter this option, you can also write like this, option D, because EX is more than red, right? Radio waves. But radio waves is less than electromagnetic waves. Radio waves is less, right? Radio waves is less compared to electro. You can put like this. Electromagnetic microwaves is has more wavelength. So you can put this like this. So any either option C or option D has to be altered. Got it? Yeah. Coming to this, the magnetic field of the electromagnetic wave is given by By. And this is X. Now, what is the equation for the magnetic field wave? This is B naught sine kx omega t. What they are expecting you to find? Wavelength. Wavelength is the question mark. Now, you know the value of K here. K is nothing but 10 power 3. K is nothing but 2 pi by lambda, which is equal to 10 power 3. So lambda will be equal to 2 pi by 10 power 3. If I take to the numerator, it becomes 10 power 3. You know that 2 pi. Pi is 3.14, right? So 2 into 3.14 is nothing but 6.28 into 10 power minus 3, or lambda will be equal to 0.628 into 10 power minus 2, or lambda will be 0.628 centimeter. 0.628, that is 0.63 centimeter. So option C is the right answer. Now, electric field induced by changing magnetic field. By changing the magnetic field, you can induce the electric field. That is non-conservation. It is a non-conservation law. The correct sequence of the increasing wavelength of the given radiation is, this is more radio waves, microwaves, infrared, visible, UV, X-ray, gamma. So as we move from gamma to radio waves, you can get the increasing order of the wavelength. Increasing order of the wavelength. In order to get this increasing order of the wavelength, you have to go with radioactive source, X-ray, sodium, vapor lamp, crystal oscillator. Oscillator is having very much high wavelength. So option B is the right answer. Got it? Then, in a phase of the electromagnetic wave, it oscillates with a frequency 2 into 10 power 10 hertz. And it has an amplitude of 48 volt per meter. Volt per meter means electric field, E0. They're asking you to find what is the wavelength of the wave, lambda. Lambda. How to calculate this? E0 is given. You have to find the frequency. Instead of writing this amplitude E0, you know that the electromagnetic wave travels with the speed of light, which is given by the formula C is equal to nu lambda. What is lambda from this equation? It is C divided by nu. What is C? 3 into 10 power 8 by nu. What is nu? Nu is nothing but 2 into 10 power 10. What is 3 by 2? 1.5. When 10 power 10 goes to numerator, it becomes minus 10. 8 minus 10 can be taken as minus 2. So 1.5 into 10 power minus 2 meter. So this is the wavelength of the wave. Sir, then why they have given the E0 value, amplitude of the electric field? In order to make the confusion, they have given the value of E0. So don't get confused. So it is going to be the wavelength of the wave range only, that is 1.5 into 10 raised to minus 2 meter. So which is the right option? Option B is the right answer. I hope you understood some few MCQs in this chapter, students. Tomorrow, let me continue this remaining questions. Tomorrow, I will complete this chapter up. So in the next classes, I am going to start up with the first few portions. Thank you.